Hello, welcome. Today let's try to solve Leetcode problem 1871, Jump Game 7. So we are giving a string S. So for the S, it is always be 0 and 1. And we are also have a condition. So the first condition is I plus the mean jump would be less than or equal to z, less than or equal to mean, with I plus max jump. Yeah. So for this formula, basically this means from the first position. So let me make a drawing. So it would be like this. So for our first example, it would be 0, 1, 1, and 0, 1, and 0. Yeah. So in this example, from the first position we are at this position. So we can jump from the mean jump to the maximum jump. So from here we can jump 2 steps. So it's gonna be here, this position. Or we can jump 3 steps because the maximum jump is 3. So we can jump to this position. While we jump 2 steps at here, it is 1. We cannot jump any more because it is 1. If it is a 0, we can still jump. So from this position, we can jump 2 steps or 3 steps. If we jump 2 steps, we can jump here. And this is the end of the string. So it means it is true. Yeah. But how can we reach such a solution? So I'm gonna use the BFS to solve it. So for the BFS, basically from this point, we're gonna check. This is the first position we can reach, and this is the second position because it's the maximum jump. Yeah. But what about the next position? So this is 1 at the moment. Yeah. But if this is also a 0, yeah. So we jump to 2 steps to 0 here and 3 steps to another 0 here. And for the next layer of the BFS, what should we check? So from this position, we can jump 2 steps. Yeah. So this is 1, 2, and 3. We can jump to here. And at this position, we can jump 2 or 3. Yeah, we can jump 2 steps to this position. Yeah. But can we avoid such a duplicate? Because for the mean step and max jump, there will always be the duplicate. Yeah. So for the next step, so for example, we can jump from this position. We're gonna record the furthest jump. Yeah. So from the at the beginning, the furthest jump is 0. But while we are at position 0 at this index, so what is the furthest jump? So it is the index 0 plus the maximum jump. So it is 3. Yeah. Now, at this position, we already know the furthest jump is 3. Yeah. Now it will go to here. Yeah. If it is more than the furthest jump, we're gonna update it. Yeah. So currently from here, if it jumped 2 steps, it is here. And then if it jumped 3 steps, it is here. So from here, it means the furthest jump would be 2 plus 3 would be 5. Yeah. Now we're gonna check if this 5 it is reachable. We're gonna put it inside the queue, and also for this one. So for this part, if we jump 2 steps, we know it is 5. But do we need to put it inside the queue? We don't need, because at this position, we've already put the 5 inside the queue. But how can we avoid that? Yeah, so we can avoid that by the furthest position plus 1, because this position already at this position, we've already know it can reach the index 5. It can reach the index 5 at this position. For the next one, if we go from here, we already know it's gonna put the index 5 inside the queue. Why not? We're gonna try a bigger value, which is 6. Yeah. So we're gonna try from this position, the index is 3. 3 plus the maximum jump, is 6. And also the furthest position is 5 plus 1. Because we already know we can reach 5. Why not? We're gonna try a 6. Maybe this position can reach a 6. Yeah. We just need to check if it can reach if it can reach a 6. Yes, it can. So for this position, it will delete. It will just neglect the jump of 2, it will directly jump of 3. Maybe there is another value 0. So if it can jump 3 directly, it means we can avoid such duplicate. We can reach the destination directly. If we can reach the destination, we're gonna return a true. Otherwise, we're gonna return a false. So the hardest part for the BFS is we're gonna record the furthest. So if at this point the furthest is 5, for the next position, we're gonna try if the furthest can be 6 or not. Sometimes it can be 6. If it cannot be the 6, we will not update the result. Now let's get back to the code. So I'm gonna use the Q and F. F means the furthest positions. The Q is just a double-added Q, and inside the position will be index 0, and the furthest is 0. Now I'm gonna check this Q. So while Q, I'm gonna pop out the index I. So the index I would be the Q dot pop left. Now I'm gonna check the start position. So the start would be the maximum. So would be the maximum of I plus the minimum jump with the furthest plus 1. So this is the hard part. Actually, for the next position, we always want to check if it is possible to reach a furthest plus 1. Otherwise we have a lot of duplicate. If it can reach a furthest plus 1, it means we can jump to the next position. We will avoid such duplicate because I plus min jump may have a lot of duplicate. If we have the maximum of furthest plus 1 with I plus min jump, it means at least we avoid a lot of duplicate, and the time complexity would become On. Not On square. Now we're gonna use another index J. So for J in range start with the add position. So what is the add position? It would be the minimum of I plus the maximum jump plus 1, because in Python 1 is not included, so we need 2 plus a 1. So the minimum of the length of the string. So I'm gonna have a n. So n is the length of the string. So I'm gonna have the length of the string as I will have another variable n. So if J inside it, I'm gonna so J is the position where we can jump. So if this value of J equals to 0 string, it means we can jump to this position. So what we're gonna do, we're gonna put it inside the queue. So inside it should be the index J. Then we can check this J. If J equal to n minus 1, it means we've already reached the end of So we're gonna return a true. Otherwise we're gonna return a false. But before that, we need to update the furthest. Because for the furthest, for each of the jump, so for example, from the beginning, it is the furthest is at 0 position. But after one layer of BFS, so the furthest would be I plus the maximum jump. We are sure the maximum jump would be I plus 3. So this is a 0, 1, 2, 3 would be at this position. This is the furthest. So for each time we're gonna update the furthest would be I plus the maximum jump. And finally, if we cannot find the add position, we're gonna return a false. So this is the entire code. There's not so much coding, and the BFS is not so difficult, but the difficult part is the furthest plus 1. If we can use this furthest plus 1 and update the furthest, so this means basically we avoid such duplicate. The time complexity would become just On. Now let me just run it to check. It is not furthest because I prepared F. So it is F means the furthest. Now let me run it. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. Thank you for watching. See you next time.